Okay, I think I'm live. Let me just check. Let me just check. I think I'm live. Let me just see. Um, also logged in. Kiara, Jack is there. Okay, guys, I'm live. Yeah, it says I'm live. If I'm live, put a W in the chat because that's what you guys are all getting tomorrow. That's what you guys are leaving with. Am I live? I think I'm live. When I see the W's, that's when I'll start. I'll start. Yeah. Okay, we're live. We're live. We're live. We're live. We're live. Sorry, I'm seeing the messages. Sorry it's so late, man. I have a job, I teach all the time, like throughout the day. It's been a long day. So this was the only time I could have done it. If not, if I didn't do it at this time, then there would have been no stream today. So apologies, but I won't keep you for too long. So what we're gonna do is we're gonna just do some random past paper questions, some pure paper questions, and link in the description for the workbook so you guys can access this yourself. You can follow along. We just see we dipped from okay. I'm so cooked for tomorrow. I can't integrate or differentiate to save my life. Just you can, bro. You're good. You're good. You're good. Okay, okay. All right. So what we're gonna do, let me share my screen. How does this work again? So OBS, I'm gonna go to scene two, and then now you guys can see the questions, if I'm not mistaken. I always feel like I don't know what I'm doing with this streaming stuff. But yeah. So I've got a couple of questions here. And essentially, I feel like I've picked some questions where they can be a bit funny or tricky. So I've got some integration here, some domain and range, and so on and so forth. Okay, okay, let me see that. Am I too big, guys? Should I make myself smaller? No, I think that's okay, I think that's okay. I think that's okay. All right. So we're gonna start with this one. And let me just see what I've got. I've got a couple of questions as well. I've got some integration that we're gonna go through as well. So this one here, what's the time? It's 9 o'clock. I'm saying because you guys got the exam tomorrow, we're gonna lock it off maybe like 10 o'clock, 10:15. Yeah? All right. Okay. All right. Let's see. So what do you guys think of this question right here? So put a 0 in the chat if you think I'm cooked. I do not know what's going on here. Or put a 10 if this is absolute light work. This is not a problem whatsoever. Let me just look at the chat quick. Okay. Okay. I think I can see a couple of my students here as well, actually. Shout out Josh, shout out Jack, shout out everyone. Okay. Okay. Let's have a go at this question, yeah? So, firstly, it says find. Let me just see. Okay, cool. I've got room. You know what I'm gonna do, just so I know I've got room, yeah? Oh no. Okay. I'm just gonna make this a bit smaller. Yeah. So firstly, it says find the derivative with respect to x of ln of sine squared 3x. Right, and your answer in simplest form. Right. Now remember, when you're dealing with these types of functions here, you've got d dx, right, of the ln of f of x. Right. This is always equal to how many brackets have I got? Yeah, that's fine. Is that correct? Yeah. Do I need an extra bracket? Anyways, this is always equal to f dash of x over f of x. Yeah. So in our case, what we've got the ln of sine, and what I'm gonna do is I'm actually gonna write that squared on the outside, and you'll see why. Yeah. So with that being said, our function inside is sine 3x to the power of 2. Yeah. And by the way, the sound is all good. You guys can hear me, by the way, because I've got my laptop. I've got another laptop to the right, but it's on mute. So yeah, that's all good. Okay, cool. And no, there wasn't Michael. There wasn't a GCSE paper 2 live stream. I didn't have time to do it. I wish I could, but I'll definitely stream. I'll definitely stream for paper 3. But anyways, so we've got f of x here. So what I'm gonna do is I'm gonna say f of x is equal to sine of 3x all to the power of 2, like that. And then what I'm gonna do is I'm gonna differentiate this. Now, how do we differentiate this? This is just the chain rule, isn't it? Yeah. So it's gonna be, we're gonna bring that 2 to the front. It's gonna be 2 sine of 3x, like that. We reduce the power by 1, and it'll be times by the inside derivative of what this is here. So when we differentiate sine, we get a cosine. So it's going to be cosine of 3x. But this is another chain rule. It's like a chain rule within a chain rule. Because I've got this 3x here, I have to times by the derivative of 3x here, which is going to be a 3. Yeah? So all in all, we're going to have 2 times 3 is 6. And we're going to have sine 3x like that. And then we're going to have cos 3x like that. Yeah? So now we've got f dash of x, right? We have f of x already. That's just the function itself. So therefore, the answer for the derivative is just going to be equal to f dash of x, which is going to be 6 sine 3x cos 3x, right? Over f of x, which is just sine 3x all squared. Like that. Now let's get the question up again. It said find it, give your answer in its simplest form. So let me actually just let me grab this and put this there. So this is our question right here. This is our question right here. And this is where we're at, right? So what do we need to do? Well, we can just simplify because we've got common factors, don't we? So what do we have? We can cancel out a factor there. That's going to be, we're going to cross that. It's going to be a 1. So it's just going to be 6 cosine 3x over sine 3x, which is equal to what, guys? Can I do anything more of this? Yeah. What happened to the ln potato? Remember, when you're differentiating a function with ln x, right, or ln f of x, we're just using this rule. ln of f of x, this is equal to f dash of x over f of x. So it essentially disappears, and you're just dealing with the function inside it. Yeah, the argument. Yeah, well done, guys. Well done, MVMLS. Well done, Zikora, for evals. Yeah, fantastic. It's going to be cot. Cos over sine is cot. Remember, sine over cos is tan. Yeah, so this is actually just 6 cot 3x, and that is it. And that is part A. Yeah, good stuff. Good stuff. Brilliant. Brilliant. Well done. All right, we've done that one. I think that's all good from what I can see. I can't see anything in the chat there. So that's part A. Part I. Now part double I of A says find the derivative with respect to x of 3x to the 4. 3x all squared. 3x squared minus 4 all to the 6. So let me grab that and then do this one now. So again, remember when you do these types of questions, let me just zoom out like that there. Okay, so we're doing that. What we're going to do is we're going to say then, we're differentiating that. Chain rule problem again, isn't it? It's a composite function. It's going to be, I'll do it here. The 6 will drop to the front like that. It will be 3x squared minus 4. Take 1 away from the power, it's going to be a 5, right? That part is done. And then you're going to times by the inside derivative of this. When I differentiate that inside, 3x squared will go to just 6x within it, like that. And then the minus 4 will disappear. So all in all, it's going to be 36x. And then it's going to be 3x squared minus 4 all to the power of 5. And that will be it for 2 marks. Everybody happy with that? Yeah? Okay. Good stuff. Good stuff. So we've done that. Let us continue. So let me get part B, and I'm interested to see what you guys think of this one. So it says hence, right? Now, whenever you see that word hence, it's definitely gonna come out tomorrow, most likely. It says show that the integral of x, right, times 3x squared minus 4 all to the 5 dx is equal to r, right? Where r is an integer to be found. So what method of integration are we doing here, guys? That one is so much easier for the same amount of marks. Yeah, it is, to be fair. I think with the one before, I think it's just about the triggers in it and just cancelling out. I'll definitely try it in New Orleans. I'll see if I can get some questions. I appreciate you, Impact Man. Thank you for the nice words. What do you think of the DI method? Do you know I haven't really used it that much, but I know it's very quick. It's the DI method for by parts, isn't it? And Camilla, close, not quite. I could see a couple of us saying by parts, right? This is actually, yeah, well done, Kinu, Inuola. Yeah, it's a reverse chain rule problem. Yeah. Now, reverse chain rule, I think it's a bit split from what I've seen, right? In terms of some people like it, some people don't like it, but I think it's a really good tool, especially if you've practiced it a couple of times. It saves a lot of time. Now, when you're doing this question in an exam, yeah, you're looking at it. Have a look at what we did before, right? We figured out that when we differentiated that thing, yeah, we got 36x, 3x squared minus 4 to the 5. And if you look at this very closely, they're very, very similar, right? So the way the logic behind the reverse chain rule problem, the logic behind the reverse chain rule is this, right? You're looking at something that you're trying to integrate, and what you want to ask yourself is, well, what would I need to differentiate to get the thing I need to integrate? So what I mean by that is this, for example, if I wanted to integrate 2x, right? Well, we know, let me do this here actually, because I think my face is going to be covering it. Yeah. If I was to integrate that, well, we know we'll just do 2x squared over 2, yeah, which is just x squared. We know this, plus c. However, we know that when we differentiate x squared, we get 2x, don't we? So you could have actually just done it by inspection and said, well, I know that when I differentiate x squared, I get 2x. So the integral of 2x must be x squared. Yeah? That is the process of reverse chain rule. You ask yourself what you need to differentiate to get what you need to you ask yourself what you need to differentiate to get that. Anyways, so let's actually do the question. In the part above, we figured out that when we differentiate this thing, we get that thing. So what I always do is this, yeah, is I'm gonna grab this here like that, and this is the derivative, right, of this thing here. Yeah. So remember, integration and differentiation are reverse processes, right? So if I differentiated this thing, which what was it again? It was 3x squared minus 4 to the 6, yeah? 3x squared minus 4 all to the 6. If I differentiated this, I got this here, right? Which means that if I was to integrate this thing, right, I would go back up, wouldn't I? So I know that the integral of 36x, 3x squared minus 4 to the 5 is just 3x squared minus 4 all to the 6, right? Obviously plus c, but I'm going to leave the plus c for now. Now, what we need to integrate, if you expect it, is just the same thing, but without that 36. So I'm actually going to write that underneath, and this is what I always do, right? So x and then 3x squared minus 4 all to the 5 dx, right? Like that. Now, what is the difference between that and that? Well, the top one is just 36 times as big. So I would need to divide by 36 to get the one on the bottom, right? Now, this is an equation. Whatever I do to the left, I must do to the right. So therefore, I must times this one by 1 over 36. So the answer is just going to be 1 over 36, and it's going to be 3x squared minus 4 all to the power of 6, right? And that's it. Does that make sense? Yeah. I think I've got one. I'll try. I'll try. Your fours looking like nines, so low key. Do you know, honestly, yeah, throughout my whole life, my fours and nines are always I can distinguish them, but I've done mock exams where I've looked at them, wrote a four, then maybe I'm frazzled. I think it's a nine. I've heard that so many times, literally. But yeah, okay. I can never think about questions like that. Okay. Yeah, the fours look a bit funky. Allow me, Kabila, man. I'm gonna try my best. I'm gonna try my best. But yeah. Do I think my predicted papers are accurate for this year? I have no clue. No clue. But yeah, I know. Yeah, we're gonna do the limits in a second. I was just showing you how to do the reverse chain rule. So obviously this was a definite integral. So all we're gonna do now is just plug in our limits into our integral, right? So all we're gonna do now is remember it's between 0 and what was it? Root 2, like that. So all we're gonna do is just plug this into there, like that, 0 and root 2. So I'm going to evaluate this now. So the first one is going to be, let me just zoom in a little bit. So it's going to be there. It's going to be 1 over 36, like that. And then it's going to be 3 lots of root 2 all squared minus 4 all to the power of 6 minus, and then it's going to be 1 over 36. And then it's going to be 3 lots of 0 squared minus 4 all to the power of 6, isn't it? Like that. And then tidying that up, that's what, 1 over 36. What's that? Root 2 all squared is 2, right? 2 times 3 is 6. 6 take away 4 is 2. This is 2 to the 6, like that. And then minus 1 over 36. And then minus 4 all to the 6, no? Like that. And then now I'm just going to put this in the calculator and see what I get. Yeah? So plugging that in, that's going to be 1 over 36. 1 over 36 times 2 to the 6, like that. And then minus 1 over 36 to the power times minus 4 all to the 6. And we should get that there, minus 112. And I think that's what the answer was from when I remember it. Somebody get that as well? Caroline got that as well. Yeah, I think it's gonna be. I think about yeah, 10 past 10 at the very latest. I think because you guys got the exam and I'm an old man, so I need my sleep. Do you get me? So hold on, let me just shut my window because it's a bit. Okay, cool. So that one's done. All right. So let's go to the next question that I've got for you guys. So the next one is functions. Now this one I think is very, very split. I think we don't really like functions. Let me just see the chat. Do you guys think the paper's going to be hard tomorrow? Since both of us said their paper one was hard. Really enjoyed doing your pretty paper. Thank you for making it. You're welcome, Jeremy. Um, you done your muscle ups yet? Nah, I've fallen off, Jack, man. I ain't done them in a minute, to be fair. Guys, I can't do a muscle up to save my life, man. But I'll get there one day. I'll get there one day. But but yeah, cool, cool. No worries, Belize. Good luck for tomorrow, man. Good luck. Can you do by parts for the previous question? Technically, you can, but you don't want to do that. Yeah? Okay. Okay. Wasn't the last question 112 rather than minus 112? I believe it's minus from what I remember. Let me check. I believe it's minus from what I remember. It's definitely minus. It's definitely minus. Yeah? Okay. You're welcome, Leo. You're welcome, Leo. All right. Let's see. Let's have a go at this question, yeah? It says the function f is defined by 2x squared minus 5, where x is greater than or equal to 0, and x is an element of the reals. It says state the range of f. Yeah? Okay. So remember when you're looking for the range of a function, right? I always like to visualize it. Range is up and down, right? Domain is left and right. You're looking for the set of y values that your graph can take. So this one is very, very easy. You may not even need to draw a graph, but I would always visualize it, right? So with this one, what is this? This is a quadratic, no? So let me do it here. You know what I'll do? Yeah, no, I'll do it here. I'll zoom out a little bit. Okay, I'm gonna run out of room actually. Let me grab this and then put this down here. Okay. Okay, I'll do it here side by side. Also, guys, for anyone that wants to check the answers, the link to where I'm getting these questions from, I've put in a workbook. So just go in the description, and then if you check the other tabs over here, you can see I've got the solutions here as well. Yeah. So it's just for reference for you guys, so you can see where I'm getting these questions from, and I've got some written solutions to them as well. Yeah. So if you want to check any of the answers, yeah, just look, you'll find it. Anyways, this one we want to sketch this quadratic here. So firstly, I'm gonna do it underneath. Yeah, like that. So it's a quadratic, part A. 2x squared minus 5. Well, x squared is like this, right? 2x squared will just be a vertical stretch. Because it's a sketch, I can just say this is 2x squared as well. And then the minus 5 will just shift it down vertically by 5 units. So it's going to be like this, isn't it? Going to be like that, essentially. Like that. And then I'm going to rub these out, yeah? And then the y-intercept is going to be at minus 5, isn't it? And to be fair, it is defined for x is greater than or equal to 0. Yeah, so I'm going to rub out the left-hand side of this graph. So it's actually going to be like that. The question asks for the range. Look up and down. Well, the lowest value that this graph can take is minus 5, and it goes on forever. So therefore, the range is going to be f of x is just greater than or equal to minus 5. Does that make sense, guys? Happy with that? Yeah? They're just common topics, Nevin. They're just common topics. Yeah? Cool. So it's gonna be greater than or equal to though. Yeah? All right. So now, part B, it says on the following page there is a forgot to get the diagram, you know. Hold on one second, guys. I need to get rid of all of these. Let me close these tabs here. Oh, where's the diagram? Oh, what does it say? It says a sketch of code y got f of x. Okay, to be fair, I don't need it, yeah? Because yeah, that's fine. Or you know what? Yeah, let me actually give me a second, guys. Let me actually get the graph. Is it from this paper? I think it's from one of these ones. Where would the question be? Yes, that one. Perfect. I actually got it here because I did the solutions earlier, just in case in case I didn't do this question, I've got it here. So this is the graph that they're talking about, yeah? Okay. It's much better than mine. But anyways, And let me write -5, by the way, because this is 2x squared minus 5, isn't it? What does it say? We need to sketch the inverse. Yeah. Now it's only 2 marks, right? This question, they don't expect you to actually find the inverse function, although you can. You just need to remember the relationship between the function and its inverse, right? They reflect in what line, guys? Exactly. Y equals X. Well done. Yeah. Well done, UK. And appreciate Nevin, man. Yeah. Crossbar is my thing. I can't lie. I might do a little series. I can't lie, you know. Anyways, the graph, the original function f of x and the inverse reflect in the line y equals x. So what you want to do is you're going to just draw a line y equals x there. We know it looks like that, like that. Now remember, function and its inverse, the x's and y's swap around. So if the y-intercept was -5 for my original function, the x-intercept is going to be -5 for my inverse, like that. And then it would just literally be like this, wouldn't it? Like that. And that would be the answer. Does that make sense? What did it ask us for? What does it say? Does it say shows a sketch the curve? It doesn't say anything about intercepts or anything like that. So this should be good. Yeah. And another thing is, remember when you're dealing with domain and range, yeah, I think a good habit is to actually always set out what the domain is and the range. So remember with this one, x is greater than 0. X is greater than or equal to 0 was the domain of the original function, and the range was f of x is greater than or equal to -5. For the inverse function, these swap over, don't they? So I always do this little like diagram when I teach this. So f of x here, and you've got f minus 1 of x here, right? These are both functions. They're both going to have a domain and they're both going to have a range, aren't they? Yeah, so I do domain range and then domain range like that. Yeah. Now, the domain of the original is the range of the inverse, and the range of the original is the domain of the inverse. Yeah, just cross them like that. Does that make sense? What's happening? What's happening? What's happening? Who's spamming? 1 second. Hold on. Jack, drop a message. I'm gonna make you moderator if you're still in here. Yeah? Okay. So Ollie, you'll be fine. Anyways, yeah. So with this one here, what was the domain? It was x is greater than or equal to 0, like that. And that would mean that the range of the inverse function is going to be f of x is greater than or equal to 0, like that. And then what was the range of the original function? Wasn't it f of x is greater than or equal to -5? And that would mean that the domain of the inverse is going to be x is greater than or equal to -5. Does that make sense, guys? They just literally swap. Hold on. That doesn't look great at all. Like that. Does that make sense? Okay. Okay, Jack, I see you. How do I make you add as moderator? To manage block words, change standard record, remove chat. Which one do I want to make you, Jack? Manager moderator or standard moderator? Can review and remove chat messages and hide put users in timeout. Okay. I think I'm gonna go with can I'm gonna just go standard. I'm gonna go standard. All right. So, are we all happy with this, guys? Yeah. Good stuff. Can you early finish in 30 minutes? I don't know. I don't know. I would recommend that you just use all the time though. But yeah. So that's done, right? Okay, now what was the next question? It says the curve of equation y equals f of x meets the curve of equation y equals the inverse of f of x at the point P. Use an algebra and show in your working, find the exact x coordinate of P. So visually looking at the diagram, right, it's where these intersect. Now, you may just be thinking straight away, well, what would be, well, we know what the original function is, f of x is equal to 2x squared minus 5. You may say to yourself, okay, well, let me find out what the inverse is and equate them, yeah? So, uh, we're gonna do. You're not gonna do this, by the way. I'm just gonna show you what the inverse is anyway. Y equals 2x squared minus 5. Swap the x and y's. X is gonna equal 2y squared minus 5. Add the 5, divide by 2 square root. X plus 5 over 2 is gonna equal y squared, and then we're gonna square root, aren't we? So it's gonna be square root of x plus 5 over 2 is going to equal y, and obviously plus or minus. But remember, this is your y, this is your function, right? Remember, the range of your inverse function is greater than or equal to 0 right here. So this one, we know that we can disregard the negative solution, yeah? So therefore, your range is going to be this. So, or your inverse, I should say, is going to be that, yeah? And you may be thinking, well, this is the function, this is the inverse function. I've got the function. You just make these two equal to each other, right? And you'll get this. You're going to get 2x squared minus 5 is going to equal the square root of x plus 5 over 2. And then how do you solve that? You square both sides and so on and so forth, yeah? Okay. How do I... Okay, this guy, hold on. How do I... I'm gonna put you in timeout. I'm gonna put you in timeout. You get 5 minutes. I'm gonna put you 10 minutes timeout because you've been doing a lot. Yeah. So you're in timeout. If you come back and you're doing that, then you're removed. Okay. 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 Please beat this comrade guy. Okay. I've put him on timeout. Yeah. So if he comes back and he's doing that, then I'll just remove him. So when you're here, guys, you may be thinking, okay, I need to solve this, squaring it and so on and so forth, but you don't need to do that. Look at the graph, right? The point P is the point of intersection, right? The line y equals x, right? That point, that line is part of that point P, isn't it? It's also, so there's like 3 points. It's 3 parts. There's the two graphs, the two curves, and that line. The line y equals x is a linear function. It's super easy. Just make your quadratic equal to your linear function and solve that instead. So you don't actually need to do this. I was just showing you just in case you guys thought to do that, yeah? So what you're going to do is you're going to solve 2x squared minus 5 is going to equal x. And then that would mean that 2x squared minus x minus 5 is equal to 0. And then you just plug it into your calculator and call it a day, right? So put this in here. I'm going to go down here like that, and then 2, and then I'm going to do 2 here. It's going to be 2 minus 1, and then minus 5 like that. And I get 1 plus root 41, yeah? So x is equal to 1 plus root 41 over 5. Obviously, it's probably going to be a negative solution like that, but we don't want that because that's going to be negative. We can see from the graph, the visual aid, that we're looking for a positive x value, yeah? So the answer is just going to literally be this one. Does that make sense, guys? Happy with that? Yeah? Miller, I would, because I think in terms of just being able to find a range, it's just easy to visualize it. Sometimes you don't need to, but I don't have good eyes in general, right? I wear contact lenses, so I kind of think of it like that. I can't see well, so if I'm doing a question, I want to visualize it. Yeah. So cool. When you flip the range and domain, would the sign flip too or nah? No. Then you're able to prove the acute angle transformations for sine and cosine. The acute angle transformations. What's that one again? Is that the R sine cos stuff? Is that what you're talking about? Yeah? Okay. Miriam, just for time, yeah, I'm just gonna go to the next question. But remember, you can you can watch this back, but I'll just go through it briefly. So what I've done, so the part C asks us to find the exact coordinate of P, right? Visually, poi. P is the point of intersection. P is the point of intersection of the two curves, right? Now the curves are the inverses of one another. So we know that it reflects in the line y equals x, which will also have to go through. That point of intersection, right, is going to be an invariant point on both curves, right? The line y equals x goes through that point P. So instead of equating the two curves, right, which is what I did here, instead of trying to solve this equation, this is no good, right? Because you have to square both sides. You're going to get a quartic on the left. It's no good. What you want to do is equate the quadratic with the linear because it's the same solution because they all intersect at that point P. Does that make sense, Mariam? I hope that makes a bit more sense. Yeah? Okay. So let us continue and see how we get on. Yeah. How do you find the infinity thing with the range when it's an exponential graph? I think you're talking about when you have those exponential modeling questions and it's like maybe 1 over e to the t or something like that. And as t gets really, really big, right? This will go to e to the infinity, which is really small. So maybe you have like, for example, hold on, because I think I'm getting away. Maybe you have, for example, 5 plus 1 plus e 1 over e to the t, for example, what happens as t gets really, really big? You're going to have 5 over 1 plus something that's incredibly small. So this will, the limit of this will be 5. I hope that makes sense. I think that's what you're talking about anyway. But yeah, that one's done. What are we going to do now? We're going to do, let's do some trig. Let's do some trig. Let's do some trig. So let's do this one. Let's see how we go on. I think we're going to do this one. Then I've got an integration question and then I might call it a day, I think. Anyways, let's see. Yeah. So this one, typical question. It can come up in either paper 1 or paper 2. It comes up every year. How do we find identities, guys? Put 0 if you're cooked, you don't know your identities, or put 10 if you know them very well. Any question that they throw at you, whether it's tomorrow or next week, you're gonna get full marks on this. What do you guys think? Yeah. Just see zeros, tens, twos. Nah, guys, you guys got this. You guys got this. Yeah. Okay. Let's have a go at this one and see how we get on. So it says prove that 2 cosec squared 2 theta times 1 minus cos 2 theta is identical to 1 plus tan squared for 4 marks. So guys, the double angle formulae, I believe, is not in the formula book. So you need to know these, right? And I would highly recommend that you memorize these because there are a lot of identities in the formula book, but they're not gonna flow if you don't know these off by heart. You need to really memorize these identities because you need to be able to spot what goes where and what to do. So when I'm looking at this question, right, the first thing that I see is 1 plus tan squared on the right hand side. That is a Pythagorean identity. I know that that's sec squared straight away. So for me, I'm gonna just write sec squared here. And that just tells me that when I work with the left hand side, I know that I want to get a sec squared, which again is equal to 1 over cos squared. Yeah. So I just need to show that I get 1 over cos squared essentially. Yeah. Now, how do we do that? Let's write out the left hand side again. So I've got 2 cosec squared 2 theta, like that. And then I've got 1 minus cos 2 theta, like that. All right. Now, firstly, identities, identities, identities. I've got cosec squared here. That is 1 over sine squared. So it's going to be 2 times 1 over sine squared 2 theta, because that angle's 2 theta, times by 1 minus cos 2 theta, like that. And then I can just rewrite this as 2 minus, you know what I'll do actually, just so it's super clear, yeah? 2 times 1 minus cos 2 theta over sine squared 2 theta, like that. Right now, remember what I'm trying to show. I'm trying to show that I get 1 over cos squared, which is sec squared, which is 1 plus tan squared, right? Now, when I look at the left hand side and where I'm at now, my problem, right, is the fact that I've got this cosine of 2 theta. This argument is too big, right? I want it all in terms of theta. So what identity do I think I'm going to use here, guys? If you start on one side, guys, you have to use that side. So if I start with the left, I have to use the left, right? And show that I get the right. Remember, it's an identity, not an equation. I can't move things left and right if you want to prove it. Yeah? So double angle formula. Exactly. Yeah. So cos 2 theta, like that. There are 3, isn't there? There's cos squared minus sine squared, like that. Right? There is 1 minus 2 sine squared theta, like that. And there's 2 cos squared theta minus 1, like that. Right? Now, which one do you guys think we're going to use potentially? Maybe. Oops. I just realized I've just written that should be a 2 theta at the bottom, isn't it? My bad. My bad. My bad. Yeah, 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 yeah. I was thinking something's not right. Thank you guys. Let me write this again neater. Like that. So it's gonna be a 2 theta there. Like that. Perfect. We happy with that, guys? My bad. Sorry guys, 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 sorry guys. Sorry guys. Apologies. Okay. Okay. Cool. So we're here now. Okay, this makes things a lot better now. All right. So Yeah, this makes things a lot better. So what I'm gonna do, right, is just because I want what do I want? I want 1 over cos squared, don't I? Yeah. And this sine squared 2 theta, this is another double angle, right? I'm gonna choose just because I'll show you why. Sine squared 2 theta, that's the same as sine 2 theta all squared, right? Like that. And then this one inside double angle is going to be 2 sine theta cos theta all squared. Yeah. Now, because I've got a cos squared theta there, right? And I know I need 1 over cos squared eventually because I want 1 plus tan squared, which is sec squared. I'm going to choose this one on the top because hopefully the sine squares will cancel and I left with a cosine. Does that make sense? So I'm going to choose the second identity. So it's going to be 2 and then, or you know what I should do actually? Let me actually just, I might as well expand it, isn't it? We just see what we've got there. Yeah. What I'll do, yeah, I think I'll just do it. I mean, it doesn't really matter to be fair. Let me just I'll do it. So what I'll do is let me just put this here. I'm gonna do 1 minus, and then it's gonna be in a bracket. It's gonna be 1 minus 2 sine squared, isn't it? Like that. Like that. And then obviously that's gonna be 2, and then that's gonna be 1 minus 1 plus 2 sine squared theta like that. And then that is gonna be 1 take 1, which is 0. So it's literally going to be 2 times 2 sine squared theta on the top. So the numerator is going to be 4 sine squared theta, isn't it? And I hope I'm not running out of room. Let me just put this like that. Does that make sense, guys? We happy with that? Yeah? Okay. So now I'm here. And then that's going to be, the denominator for here is going to be 4 sine squared theta, cos squared theta, like that. And then that's going to be 4 sine squared theta and then cos squared theta. Now remember what you're trying to prove. Always have the show that at hand, right? We're trying to show that the right hand side is 1 plus tan squared, which is sec squared, which is 1 over cos squared. And what we have here, right? What we have right here is we have cancel, 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 cancel. This is just 1 over cos squared, like that, which is sec squared, right? Which is 1 plus tan squared, like that. We done it. Does that make sense, guys? Everyone happy with that? Well done, Maya. Good stuff. Yeah? Okay. Cool. Brilliant. Brilliant. So I think we're all good with that. Okay. All right. So let's go to part B. Yeah? Part B says, hence solve for 0 to 360, where x is never equal to 90 n degrees, where n is a natural number. The equation of 2 cos x squared 2x times 1 minus cos 2x is equal to 4 plus 3 sec x. Yeah? Giving your answer to one decimal place. Solutions relying entirely on calculator technology are not acceptable for 4 marks. Thank you very much, Posted. Without you and Neil, I would have been finished. I really appreciate it, man. Neil's a great guy. Sick guy, man. Sick guy. I'm sure his stream went well as well. How many more questions will you be going through? I think I'm gonna do I'm gonna do an integration question after this, and then maybe I'm gonna do like a couple of like tips for tomorrow. So it's not gonna be too long of a stream. Yeah? Chat, I've got GCSE tomorrow. Why am I watching A-level maths? Because you want to join the party, bro. Good luck for tomorrow, my guy. I'm sure you're gonna do well, and I'm sure in a couple of years you'll be doing A-level maths as well, and you'll be joining me with these streams. Anyways, yeah, let's have a go and see part B. Yeah. Okay. Remember, part A, part B. Look at these; they're the exact same. The only difference here is that the theta is now an x. Yeah. We've proved in part A that this on the left is 1 plus tan squared, right? So this on the left we can write as 1 plus tan squared x, isn't it? So let me just grab this here, and then I'll just start solving it. So let me just do this here. Okay. All right. So next one. Okay. So with that being said, we know that this is 1 plus tan squared, isn't it? Right? So I'm going to put this here. This here in a square bracket. We've proven in part A, that's 1 plus tan squared. So I'm going to write 1 plus tan squared x, like that, is going to equal 4 plus 3 sec x. Right? Now, here, remember, you've got a sec x on the right. It's not being squared, right? So there's not really much you can do with that, right? So what you want to do is get everything in terms of this trigonometric expression. Just due to the fact it's not being squared, you can't really do much of it, right? You can write as 1 over cos, but you don't want to do that because we know that 1 plus tan squared is sec squared, yeah? So we can actually just write this as sec squared x is equal to 4 plus 3 sec x. And then now this is just a quadratic equation, isn't it? So doing that, put everything from right to left, it's going to be sec squared x minus 4. No, let me put that one first. Minus 3 sec x minus 4 is equal to 0. Yeah? So now we just need to factorize. This is not even a bad factorization. Sec x there, sec x there. What two factors of minus 4 are going to add to make a negative 3? That's going to be a minus 4 and a plus 1, no? Yeah. So that means set each of these brackets equal to 0. You're going to have sec x is going to equal 4. And you're going to have sec x is going to equal minus 1. Now remember, sec is 1 over cosine. So all you need to do to get it in terms of cosine, which you want to do because your calculator doesn't have sec. I don't even think the CG50 has sec, right? You're going to change these to cosines, yeah? And you're just going to literally take the reciprocal of both sides. I'll just write it like this just so it's super clear, yeah? 1 over cos x is equal to 4. That means that if I divide by the 4 times by the cos x, I have 1/4 is equal to cos x, yeah? But you don't need to do this. You can just literally take the reciprocal. The reciprocal of sec is cosine. The reciprocal of 4 is a quarter. Yeah. Which means this one is going to be cos x is equal to minus 1. Yeah. So these are going to be our two solutions. Okay. Well, they always tell you if it's in degrees or radians. If they don't, do you just assume radians? If you're doing calculus, if they ask you to differentiate, then you're going to do radians. But this one, they've given it to us in degrees. So we know we're dealing with degrees. Yeah. So we need to solve both of these equations. So it's between 0 and 360 as well. So what I'm going to do is in degrees. My calculator is in degrees. So I'm going to just take the cos inverse of that. Cos inverse of a quarter. And how do you guys solve trigonometric equations, guys? Do you guys do the cast method, the cast diagram? Do you guys sketch the graph, or do you guys memorize? I personally just memorize them. I think it's just the most efficient way. So firstly, what I would say is that x is going to equal for that one. It's going to be 75.52 blah blah blah, 52 blah blah blah. And then the next one is going to be 360 degrees minus x. That's how I always remember it. So you got x there. The next one is 360 minus whatever that is. And then to get the next ones after that, or the ones before that, you just add 360, don't you? Yeah. So I'm going to just do 360 minus that. 360 minus answer, like that. And I get 284.4 blah, 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 right? And these are going to be the two answers. So that's going to be 75.5 degrees, and that's going to be 284.5 degrees for that one. And then now we've got those cos x equals minus 1, like that. What is that equal to? Again, cos inverse, that's just going to be, you can even draw the graph as well. Minus 1 is down there. It's going to be 180, isn't it? But let's just check anyway. Cos inverse of minus 1 is going to be x is 180. So we've got three answers. X equals 180, right? That's the third one. And we've got these two. However, there's a problem here. Now I'm going to put the question here. And these are the three solutions we get. However, one of them is invalid. Can somebody tell me which one it is and why? So let me grab these here. These are our three answers. One of them is invalid. And which one is it? I think 3M. If it doesn't specify, I would leave it to reasonable good figures. Yeah. Well done, Arsen. Well done, Maya. Good stuff. Well done, Zainab. It's 180 because it says quite clearly that x can't equal a multiple of 90, right? 180 is two lots of 90. So we can't use this one. So therefore, your answers are just going to be these two. Yeah? Does that make sense, guys? We happy with that? Yeah? Remember, it's not outside the range because the range is between 0 and 360, isn't it? Yeah? So just be aware of that when you see these types of questions. You've got to be a bit careful. Yeah? Okay. Okay. Cool. Happy with that? Everyone happy to move on to the next question? Don't worry, Francis. You're good. It's not GCSE. Yeah? You can go down. There's nothing down here. If this, okay. Do we not divide by two? No, not with this one. Just because of the fact, right? I know what you mean. Just because of the fact that we've got these two x's here, but we replace this two x right with a expression with just x's. So we're just solving an equation in x's. Does that make sense? Yeah. Good stuff. Good stuff. I believe that's it. Yeah. Perfect. Okay. Cool. So, yeah. Let's continue. Let's continue. Okay. So let us do this one. See how much time we've got. Hopefully we can do both parts, but anyways, we'll see. So integration, guys, right? I think one of the hardest topics in A-level maths for sure, right? What do we think about this question right here? Put a zero if you think I'm hooked. If this comes up tomorrow, I have no clue what to do here. Or put a 10 if this is light work. This is an easy 9 marks in the bag. No ifs, no buts. Good night, Iman. Good night, Iman. Good luck. Good luck, man. You're gonna do really, really well. No, do parametrics. There's a couple parametrics in my predicted papers. I love this question. Zeros, zeros, five, eights, tens, 9.5, twos. No, you guys got this. You guys got this. You will never be cooked, Kirsty. Ever. All right. So now let's do part A. Yeah? I'm gonna do it not quick, but like I'm gonna do it so we've got time. All right. So it says part A, it says using a substitution, u is equal to root 2x plus 1. Show that the integral between 4 and 12 of root 8x plus 4, e to the root 2x plus 1 dx may expressed in the form of the integral of a and b, ku squared e to the u du for 4 marks, where a, b, and k are constants to be found. All right. Now, firstly, um, to be fair, I don't even do this first, but I'm doing it firstly. I'm gonna just change the limits, right? So I know from the original integral that I'm integrating between x equals 4 and I'm integrating between x equals 12, aren't I? Yeah. So if u is equal to the square root of 2x plus 1, right? Then, well, when x is equal to 4, then that means that u is gonna equal um what's that? 8 plus 1, which is 9, which is gonna be 3, isn't it? Yeah. And then when x is equal to 12, what's u gonna be? U is gonna I wrote y. U is gonna equal the square root of 24 plus 1, which is 25. So it's gonna be 5. Yeah. So A and B are 3 and 5 straight away. Yeah. A equals 3, B is equal to 5. So we've got our limits of integration. Now the nitty-gritty part. Yeah. So let me grab this again and then let's see what we need to do here. Now, immediately when I look at this integral right here, right, I notice, let me get the substitution again. U is equal to the square root of 2x plus 1, like that. This root 8x plus 4, right? The 8x plus 4 is 4 times 2x plus 1. No, that can't be a coincidence. So what I would do is actually rewrite that. I would say then that the root of 8x plus 4, right? This is the same as the square root of, I can take out a 4. It's going to be 2x plus 1, isn't it? Like that. And then from our third laws, we know that we can split a product. So it's actually root 4 and then root 2x plus 1. Like that. The square root of 4 is 2. The square root of 2x plus 1 is u. So that's just 2u there. Do you guys agree with that? Does that make sense so far? Happy with that? Yeah? Well done, Shine Motivation. Good stuff. Yeah? So with that being said, the integral, right? Remember, we're integrating between 3 and 5. We've already changed the limits. The square root of 8x plus 4 is just literally 2u, like that. And then I've got e, right? And then the power is root 2x plus 1, which I know is u. And then I've got dx. So the only thing I need to do now is just change the dx. Yeah? Wait, what happened to the e again? The e is there. Let me just see. Yeah? Yeah, this is from an international paper, Jack. I can't remember which one though. Yeah? Yeah? Everybody happy with that? Anybody got any questions on that? You just see? Why is it not for you? Because it's root 4, isn't it? That root is over the 4 as well. So you have to square root it, so it's 2. Yeah? Okay. Now, what do we need to do? We need to get rid of that dx. Now, we know that u is equal to root 2x plus 1. What I'm going to do is I'm going to change this 2x plus 1 to the half. And then now to get the dx part, we need to just differentiate, don't we? Yeah? So it's going to be du over dx. This is going to be the chain rule. It's going to be a half, and it's going to be 2x plus 1. Take away a half. Take away 1, which is going to be minus half. And then we're going to times by the inside differential. Differentiated inside is going to be 2. The half and the 2 cancel. It's just literally going to be 2x plus 1 to the minus a half. And that's the u over dx. And now remember, we want dx, so just rearrange. It's going to be, and you know what I'm going to do actually, before I rearrange it, right? Because I've got that 2x plus 1, I'm going to rewrite this as a fraction. This is 1 over the square root of 2x plus 1, isn't it? Like that. So therefore, dx is going to be root 2x plus 1 du. When I times it up, that's going to equal dx. And obviously that thing there is u. So it's u du is going to equal dx. Does that make sense? Good night, Zakir. Good luck for tomorrow, bro. You're gonna do really, really well. Yeah? 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 Good stuff. Good stuff. So now, doing this, we can plug that in, can't we? So it's gonna be the integral. So I'll put this here. Now it's gonna be the integral between 3 and 5 of 2u e to the u, and then dx is u du. Yeah? So therefore it's gonna be 2u squared, u is u squared, e to the u du. And then that's going to be between 3 and 5. So A is going to equal 3, B is going to equal 5, and K is going to equal 2. And that's the answer. Does that make sense, guys? We happy with that? Anybody got any questions on that? I think it's all good, isn't it? Yeah? Good stuff. Good stuff. Good stuff. Brilliant. Okay. Okay. How did make it messed up? So scared. Got any trigger integration coming up? Not today. Not today. But I've got some in my predicted. Yeah. Okay. Can you do the last bit again? Hold on, let me just see. The one that has two of the same name documents. Which one are you currently on? Oh, so yeah, my bad. Because I think I was just in a rush and I was doing it. I'm currently on the top one. Yeah. So, if you go to the top one and then I'm just moving this around, yeah. So it's a bit of a mess. I can't lie. The questions are here, yeah, it's a mess, man. It's a mess. I've copied the same question, put underneath, but I'm on the top one and then I'm all the way down. So hopefully, that makes sense. Yeah. I think what I'll do when I get a chance when I end this stream, I'll organize the document so it's easy to follow. Yeah? Okay. So yeah, good stuff. Yeah, that's the answer to the next one. Let's do the next one now. And then after that, I think I might call it a night. Let me just see. So that was part A. Part B. It says, hence find by algebraic integration the exact value of this integral here. And this is the integral in part A, which we found the substitution for. So what you want to do essentially is integrate what we got in part A. Yeah. So instead of integrating this thing, we need to use substitution, right, to get it in this format here. And then now, what method of integration are we going to use? So for part B, let me just copy it. Part B is there. And then we are integrating this here. How are we going to integrate this, guys? Not this thing. We're going to integrate this thing here. What are we going to do to integrate this? Why is root ax plus 4 not 4u? Because when you take out the 4, right, there's a square root, there's a roof. I'll do it again. Root ax plus 4, like that. If you take out a 4, it's going to be 4 bracket 2x plus 1. Remember your surd laws. Root a times b, right, is root a root b. So this one is root 4 root 2x plus 1. This here is u. Root 4 is 2. It's 2u, not 4u. Does that make sense now? But yeah. We're gonna use by parts for this one, aren't we? Yeah. So let me move this to the side, yeah, and then we'll do this by parts. And then, so what's the time? It's 9:54. I wonder how long it's gonna take me to do this. So, okay. So because I need to integrate this, right? Now we're doing by parts. How do we know we're doing by parts? Whenever you're integrating a question, right? If it looks like a product rule problem, then it's gonna be a by parts, right? Now what I mean by that is when you actually when you are what are you doing? When you're proving integration by parts formula, you actually use the product rule to do it. Yeah. So just as a rule of thumb, if you've got an integration question and it looks like if you were to differentiate the thing you're integrating with a product rule, it's going to be a by parts problem. Okay. So, yeah, we're going to use by parts for this. So, what is the formula for by parts? The formula is v du dx, right, is equal to uv minus the integral of udv, isn't it? Yeah, like that. So you want to choose something to be your v, and you're going to choose something to be your du. Now, just because the formula for by parts has u's in it, right? What I'm going to do is, just because I don't confuse myself, I'm going to just change this to x's. It's not going to change the answer. It's a definite integral. I just need to figure out what the area is. But I'm going to just replace the u's with x's. Are you guys happy with that? Just because I'm going to use the formula for by parts and it has u's in it. Does that make sense? I'm just literally um um and by the way, that is a V, by the way. It doesn't look like a U though. It is a V. That is a V. It's just the way I've written it. Let me do it like a modular sign. That is definitely a V. Yeah? Happy with that? No, you don't need to be able to prove integration by parts. Yeah? Okay. So now we need to integrate this. So we're going to choose something to be your V. What are we going to choose to be V? The thing that we differentiate. And what are we going to choose to be our du, guys? You miswrote the formula. No, I think, no, this is fine. This is fine. Yeah? Yeah? Okay. So, oh yeah, you could use that LIA acronym, right? What I like to do is just say to myself, okay, well, fine. What would make life easier? If I was to differentiate 2x squared, this is a polynomial, the degree will drop by 1. So I'm going to choose this to be the thing I'm going to differentiate, right? dv dx is going to equal 4x, right? And then the thing to integrate is going to be e to the x, because that just stays the same, doesn't it? Yeah? So that will be that. We happy with that, guys? Yeah, good stuff. So now, doing this, we're going to use the formula, right? So the formula says that this is going to be u and v. So u and v are going to be these two. So I'm going to times these two together, and I know it's a definite integral, but I'm going to just do it without the limits first. So it's just going to be uv is going to be 2x squared e to the x, right? Minus the integral. Let me just write this here so it's clearer. Minus the integral of these two, 4x e to the x dx. And this is the integral of that thing. Yeah? You guys happy with that so far? Yeah? Good stuff. Let me just make this a bit neater. Hold on. Let me write it again. What is it? 2x squared e to the x dx. Yeah? All right. So now what I'm going to do is look at what I've got here on the right hand side is this here. I now actually have to use by parts one more time, don't I? Yeah, because again, this is like a product rule problem. And again, what I'm doing is it's a definite integral. I'm going to find out what the full integral is first, and then I'm going to put the limits on. You can do it halfway as well, but I just like doing it this way. Yeah. So I'm going to integrate now 4x e to the x dx. Let me just check the chat just so I'm sure that we're all good. This is not higher. This is A level. This is A level. So you are in the wrong stream. But yeah, feel free to. If you've got an exam tomorrow, I recommend going to bed because your time's in the morning, actually, isn't it? So yeah, okay. Now we're gonna do by parts with this one again. So again, simply we're gonna choose this to be our v 4x. We're gonna choose du dx gonna be our e to the x, like that. So we're going to I'm headed off to bed. Thanks so much for your hard work, Karen. Revision last 2 to go. Appreciate you, Haraya. Hope I pronounced your name correctly. Good luck for tomorrow. You're gonna do really, really well. So yeah, the v over dx, differentiating that, is gonna be a 4. And then integrating du is gonna be e to the x, isn't it? And then again, using the formula, it's going to be u and v, these two right here, is gonna be what's that gonna be? 4x e to the x minus the integral of these two, like that, udv, yeah, which is gonna be 4e to the x. And then that one is super easy now. This is 4x e to the x minus the integral of 4e to the x is just 4e to the x, isn't it? Like that. And then now what we've worked out is the integral of this thing. We've worked out the integral of 4x e to the x, haven't we? So now what we can do is plug that in there. Yeah. So remember, we were at this point. I'll copy that here, like that. And we now know what this thing in blue is now. This thing in blue right here, right, is this thing. So now I can actually just replace it. Yeah. So it's going to be 2x squared e to the x minus, and then in a bracket, what we got here, which was that. Minus 4e to the x, like that. And then now just tidying up a bit more, just expanding that minus, could be 2x squared e to the x minus 4x e to the x plus 4e to the x, like that. Does that make sense? Shout out James Ollie, man. James Black, you're gonna do really well, man. You're gonna do really well. Shout out Ollie, shout out James, shout out everyone. Yeah? So we're here now. And then now what we're gonna do essentially is just literally apply the limits now, aren't we? Yeah? Just checking the chat, we're all good. Yeah, cool. So all we're gonna do is put the limits in. Yeah? Now the limits between 3 and 5, wasn't it? So it's gonna be integral of 3 and 5 of that thing. It's just gonna be like that. 3 and 5. Yeah? So what we're gonna do now is just plug this in. So it's gonna be 2 bracket 5 squared, like that. And then e to the 5 minus 4 lots of 5 e to the 5, isn't it? Plus 4 e to the 5, no? Take away, and there's going to be 2 3 squared e to the 3, right? Minus 4 3 e to the 3 plus 4 e to the 3. No? I think that's okay. I don't think I've made any mistake. If you wrote u instead of x, would you lose marks? No, you wouldn't, Matteo. I'm just writing that just because of the fact that it's just easier for me to look at and I won't make a mistake because you know the by-part formula has u's in it, yeah? So you won't lose the mark. The answer um is a definite integral. They're looking for a numerical value. As long as you get it, you'll be fine. Yeah. So yeah, let's evaluate this now. Did they ask for an exact value? I'm sure they did anyway. Hence, find the exact value, of course. So we need it all in terms of e. So we need to evaluate this. So what's that? Let me just make sure I don't make a mistake. 5 squared is 25. That's 50 e to the 5. That's going to be 20 e to the 5, like that. Plus 4 e to the 5. Minus, and then that's gonna be, oh, that's a squared, isn't it? 3 squared is 9. That's 18. Minus, that's gonna be 12 e to the 3 plus 4 e to the 3, like that. What's that? 50 take away 20 is 30. That's 34 e to the 5. And then that's going to equal, what's that? 18 take away 12 is 6. 6 plus 4 is 10. So the answer is going to be 34 e to the 5, 10 e to the 3. Does that make sense, guys? Happy with that? Just check that as well. Yeah, perfect. Yeah, brilliant. I think somebody else got that as well, didn't they? Yeah? Okay. Goodbye, Christian. Good luck. Good luck for tomorrow. You're going to do really, really well. Yeah. For vectors and 3D, would I have any suggestions on where I can find revision tools for vectors? I think maybe like PMT, maybe. Do you need to put in calc for exact value? What do you mean by that? Put in calc? Put in a calculator? That what you mean? Yeah. But but yeah, how many questions did we do today? It's about 10 o'clock. Time. So we did that one. We did that one. We did four questions. I think that's reasonable. Um, so what I'm gonna do now is I'm just gonna give you just like a couple of tips for tomorrow. Yeah. So, um, firstly, what can I say? What can I say? Don't go to bed too late. Um, how do I go back actually? Let me go back. Is it Big Cam here? Yes, I think I'm back here now. Oh my days, I'm so tired. Anyways, yeah, tip number one is I always say this, right? When you're doing show that questions, like the one we just did now, um, if you can't do a show that, that doesn't mean you can't answer part B. So I see a lot of the time, students will look at a show that and they can't do it and they just leave the question. Remember, show that's are just a guide to help you with the next part. If you can't do the first part, you can't show it, you can still use it. Another thing as well is you need to treat the exam like it's like a factual exam, right? You need to be able to. Oh wow, excuse me. You need to be able to know your facts. So, for example, what does a stationary point mean? Actually, now that I've got this, I just remembered something. I've actually got something I want to show you guys. I've got these formula sheets here. Yeah. So you need to remember what a stationary point is, right? Stationary points are when dy dx is equal to zero. Yeah. A function is increasing when your gradient function is positive. It's decreasing when it's negative. Stuff like that, right? Because they will ask you, show that a function is increasing and stuff like that, and it's just about the gradient. Sometimes they may ask you to actually explore the actual algebraic function itself. You got your log laws here. So this is all in the description, this link to this here. Just go and formula sheets, you'll see this here. What else is there? You got your standard derivatives, reminder of differentiate ln of f of x. Just see. What should I do tomorrow morning? What I would say in terms of tomorrow morning, what I did when I did my exam, um, I didn't really do much in the morning, right? I think maybe I just maybe looked through a couple of questions. I didn't do any questions. I just looked through them and just say, okay, I know what to do. I know what to do here. Yeah. So, simplest form. Please explain the function. How do you know if the inverse function due to mapping? What should I do tomorrow morning? How are you able to talk to Alex as a minimum, maximum, or a turning point without doing the way? So, I'll answer the first question, right? So, what was the first question? Please explain how you know if the inverse is a function due to mapping. It's a function if it's one to one, yeah, and many to one, believe many to one. I'll double check that. And then your second question: how do you know if the y is a minimum, maximum, or a turning point without doing the second derivative? So you don't know at that point when you have dy dx, right? You have a stationary point. It could either be a maximum, it could either be a minimum, it could either be a point of inflection. You don't know. The second derivative is the verifier. If you plug in your value that you get for your stationary point, you plug it in and you get a number that's more than zero, then you have a minimum. If you plug it in and it's negative, you have a maximum. Yeah. So at the point where you differentiate and you get your stationary point, you're not sure whether or not it's a maximum or a minimum. Maybe if you have the graph and you can see, then that's fine. But just on the algebra itself, yeah. How do you differentiate a to the x? That's just implicit differentiation, right? So that's actually in my predicted paper one. So go on that, but I'll just do it very, very quickly. Y is equal to a to the x. What you're going to do is you're going to take the ln of both sides. Ln y is going to equal the ln of a to the x. You're going to bring the log, you're going to use logs to bring that to the front, x ln a, ln y, and then you're going to differentiate this implicitly, yeah? Differentiating this implicitly is going to be 1 over y, dy over dx, like that. And then this one's going to be, this is a constant here. X times a constant will just differentiate to the constant to be ln a. So dy dx, you're going to times up, is going to be y ln a. And remember, y is a to the x, isn't it? So therefore, dy over dx is going to equal a to the x ln a. That's how you differentiate a to the x. Yeah? Okay. I believe so, Dylan. So that DI method thing, I actually saw a mark scheme, and it did say that it was included, but it was in an international mark scheme. I'm not sure about the normal ones. Yeah. Do you recommend to do the paper in a specific order or just from the beginning? Elizabeth, for me personally, I would always just do it from the beginning. That's just, it's like, how do you read a book? You start from the page on and you go to the end. I've never actually done a paper where you do bits and bobs. I feel like by the time you get to the exam tomorrow, you would have done enough revision. You should be able to tackle every question. They put the questions in that specific order. You're meant to build up to it. So that's just my personal opinion, right? Which is just an opinion at the end of the day. Yeah. Okay. So is there really point in memorizing arithmetic sum proof? Yeah, it can come up. It can come up. It can come up. Can you do sigma notation? Anas, thank you very much. Concave, cover a bit of proof, please. GCSE, please. Roblox, unfortunately, not tonight. Not tonight, but definitely I'll do some tomorrow. Yeah. Um. Also, what I would say, right? Another thing I'd say as well is you guys should really have a look at your spec. So let me 1 second, guys. I'm gonna go back here. I'm gonna go to Big Cam and then let me go to my browser and then let me go to the spec and I'll just show you what I mean. Give me a second, guys. Excel A level math specification. All right, I'm gonna go to um scene two again. This one, yeah. Okay, so I'm gonna go to my browser here, and what you guys should do, you should always look at your specs. So if you're in Excel, which I know the majority of you will be, make sure, guys, before tomorrow's exam, you read through your specification. There should be nothing here that you're reading that you do not know anything about, right? It has everything in here, right? It's just a summary of everything that can come up. So this is something that I always recommend every year as well, because you can see, obviously, this is just year 12, this is even GCSE stuff here. But for example, the discriminant, right? You should know that discriminant, when it's greater than zero, you have two roots. When it's equal to zero, one root. When it's less than zero, no roots, completing the square, and so on and so forth. Set notation as well. By the way, if that set notation comes up, remember, it's just literally inequalities, right? But with this bracket at the end, right? Remember, this colon just means such that. So this is saying x is less than a or x is greater than b. This one here. In set notation, you just put the curly bracket x. The colon means such that x is less than a. This obviously is the or symbol, and then this is the other side, x such that x is greater than b. Yeah. So, doing this one, a over x b becomes, oh, this is a good one, you know. You know, this one here, this, I haven't seen this come up a lot, you know. But what you want to do with these types of questions, if that ever comes up, imagine it does tomorrow. What they're saying here, right, I'll do it here. What they're saying here is that if you want to solve this inequality and you want to preserve this direction of the inequality, you're going to times by x squared, right? Because if you were to times by x, for example, x could be positive or negative, and that could have an effect on the sign. But if you times by x squared, and that is just going to be ax there, and then that's going to be bx squared. So that's just something to make a note of as well. Going back to this diagram here. Let me just see the chat. Any major tips if you're panicking for tomorrow? Like if all else fails, remember. If all else fails, just remember the product rule. Remember what are the main topics? Integration, differentiation, calculus, arithmetic, sequences and series, geometric. So yeah, I think you guys will be fine to be honest. Um, when are you releasing Predictor Paper 2? Guys, you know, I think I didn't bang with Predictor Paper 2 because I've already released it. And I was thinking that I was going to do another predicted paper 2 based on tomorrow's paper. But I don't even have the time to do another paper. They take so much time. Um, so yeah. Oh, I didn't realize my camera's too big. Hopefully you can see that now. But yeah, proof for root 2 is irrational. Remember, root 2 is going to equal a over b. You're going to assume that they're integers. So I'm not going to do it, but root 2, you're going to assume it's a over b, and then you're going to times by b and so on and so forth, and then you're going to get to a contradiction. Yeah, have a look at that today. Um, do you have to use set notation when doing the domain arrange? No, you only need to do set notation when they ask you for it. Yeah. What to do after completing a past paper? Just take a chill pill, to be honest. Yeah. Okay. Okay. Cool. Proof of geometric and sequence. Proof of geometric sequence and arithmetic. I've got that on my TikTok. I did that last year. So if you go on my TikTok page and you scroll down to last year, I haven't made that many TikToks from between now and last year. I've got proofs on both of those on my chat on my TikTok page. Thought the reverse chain rule only works for linear equations. So why were you allowed to do x to the power of 3, to the power of 6? It just the reverse chain rule is just literally you reversing the chain rule. So as long as you can use the chain rule to differentiate something, you can integrate with the reverse chain rule, which is not exclusive to linear functions. Do you recommend drawing graphs on calculator, especially modulus functions? I think you can. I think you can do that on the CG50. Do you know what? Yeah, I'm actually not that well versed on the CG50. My student Jack, who's in the chat, he's a moderator. He loves that. Like that's his best friend. So I'm sure he will tell you all about that. Will I be online tomorrow? I don't think I'll go live tomorrow, but I'm gonna do a reaction video tomorrow. Can you integrate LNX? The way you integrate LNX is you do by parts, don't you? So integrate LNX. I think I've got that on my channel somewhere. Integrate LNX. You're gonna literally rewrite this as integrate of 1 times ln x dx, and then you're gonna choose what you're gonna do again. You're obviously gonna choose this to differentiate. You're gonna say this is gonna be your v ln x, so it's just gonna be the v dx is gonna equal 1 over x, and then u du dx is going to equal 1, u is going to equal x, and then you're just going to literally use the same thing. uv is going to be x ln x minus the integral of these two. I might as well do it to be fair because I'm here. These two there, which is going to be 1 over x times by x, which is just going to be 1. So it's going to be x ln x minus the integral of 1 dx, which is going to be x ln x minus x plus c. So that's how you integrate ln x. You split the ln x as 1 times ln x, and you do by parts. Yeah. Should I learn the DI method? I mean, I don't know. I would just do it normal by parts, to be honest. I'm not sure what the Excel says. I get how to do implicit differentiation, but I don't understand why it works. So with implicit, right, what you're doing is let's say I want to differentiate. Let's say I've got y squared, right? And I want to differentiate I want to differentiate this with respect to x, right? I can't really do that right now. So what you want to do is you actually want to differentiate with respect to y, right? Remember, my job is to differentiate with respect to x. But what I can do is I'm going to differentiate this with respect to y, like that, like that. And then what am I doing again? Times by dy over dx. So it's gonna be that's gonna be 2y, and then you're gonna times by dy over dx, just because, let me just show you here. Just because it's like a chain rule problem essentially. Because if I do dy over dx like that, can you see that that and that will cancel, and then you're left with d dx. So that's why it works. Yeah, because it's just literally the chain rule. It's like a fancy version of the chain rule. Hope that makes a better sense. But as long as you just remember when you're differentiating y squared, you times by the way, then you're fine. Yeah? Okay. Okay. So before I let you guys go, what topics are you guys looking forward to the most? That you guys know you're gonna cook tomorrow when you see it come up. How do I know when to use the reverse chain rule over parts? So Edward, the reverse chain rule, right? You'll know is when you look at the integral, you should ask yourself, can you differentiate something to get the thing that they ask you to integrate for? If you go once this finishes, you can watch the live, the first question, and then you'll see sequences in series, nothing. You guys are killing me. Rates of change. Joshua, that's you, right? That's Joshua from my groups, right? Um, cooking binomial expansion, truth. If it's not a 5 mark binomial expansion of choosing rule, I will shed a tear. Logs and exponentials, partial fractions. All right. Yeah. Now you guys are gonna do well, man. You guys are gonna do well. Yeah? Okay. Josh, I'm gonna put the recordings up tonight, yeah? Because I haven't forgotten. I've just been so busy, but I'm gonna put the lesson on the website tonight. So I'll do this after this stream, yeah? But yeah, cool. Cool. Guys, what's the time? It's 10:18. You guys need to get to bed. Yeah? Thank you very much, Edward. I really appreciate it, man. I really appreciate it. But guys, we're gonna end it here. Let me just come back here. All right. So, guys, I want to just wish you all the best of luck for tomorrow. Oh my days, I need another trim. Gonna wish you guys the best of luck for tomorrow. You guys are gonna smash it. Remember, don't panic. Just pace yourself. You guys will be absolutely fine. You guys have been doing all of the revision. It's all gonna come down to tomorrow, but it will be fine. Remember, the exam tomorrow is literally just another mock exam in a couple of years. There's nothing special about the exam tomorrow. Obviously, it's your exam, but in a couple of years, it's just gonna be another mock paper. There's nothing special about it. All of the work you've been doing, it's all gonna come through tomorrow. Okay? I'm proud of every single one of you. You guys are gonna smash it. Let me know how you guys get on tomorrow. I'm gonna do a reaction video tomorrow, and let me know what topics have come up and have not come up, because maybe I'll do a little bit of content on it as well. But yeah, good luck tomorrow, guys. Put W's in the chat because that's what we're all getting tomorrow. We're gonna leave with W's in the chat. I want to see W's. Everyone spam W's in the chat. Thank you very much, Black Alpha. I really appreciate it. BM, go to bed, bro. Go to bed, bro. It's time for bed. Appreciate you, Tom, man. Appreciate you, Tom, man. Thank you so much. Yeah, come on, come on, come on, guys. See you guys tomorrow. I'll do a reaction vid. Let me know how it goes. But peace out. Good luck again tomorrow. Take care.